So in many ways, the mean value theorem is an extension of the intermediate value theorem. While the intermediate value theorem focused on the value of a function itself, the mean value theorem focuses on the value of the derivative. So again, let's imagine we have a function that is continuous and differentiable on some interval. So what the mean value theorem says is that if you play connect the dots and find the slope of a secant line that goes from one end of the interval to another, then at some point in between, there might be more than one, but there's at least one point in between where the function has the same slope. So it has to be parallel to that secant line. So really you have to hit the average value of the slope along the way. That is the fundamental core of the mean value theorem. You can't be always steeper or always shallower, or you're not going to get there. Maybe, if you've got a linear function, you'll be riding right along it the whole way. It's a perfect fit the entire time. It might bob up and down, so you'll have 20 points that hit that value, but there's always going to be at least one in there somewhere. So for example, if we are looking at an example I am inventing as we go here. So if this is our f of x, and our interval is from 0 to 1, just to make those endpoints nice and easy to calculate. Well then, somewhere in there is a point, c, where c is in that interval from 0 to 1, where the value of the slope equals the average value. So that's f of 1 minus f of 0 over 1 minus 0. Well, f of 1 is 7, f of 0 is 1. So at some point along the way, there's at least one point where the value of the derivative is 6. So let's find all of these points. So we're looking for a point where the function is 6, where the derivative of the function is 6. The derivative here is 12x squared plus 2, because once we've taken the derivative, that plus 1 goes to 0. So then, subtracting that, we've got 4 equals 12x squared, or x equals plus or minus 1 over the square root of 3. Now we can reject the negative root, and the reason we do that is because we are exclusively concerned with the interval from 0 to 1. So the x we are looking for is 1 over root 3. We can confirm that. We can say the derivative of 1 over root 3, going back to our function, the derivative is 12x squared plus 2. So we have 12 times 1 over root 3 squared plus 2. The average value of the function we're shooting for is 6. 12 times 1 over root 3 squared is 12 over 3, which is 4 plus 2, which is that 6 we were targeting. So that is the fundamental core of the mean value theorem.